Okay, first section we're supposed to identify the domain and the range. So for the domain, we list the x values in order, least to greatest. So -3 and -1, a 3 and a 4. Since there was no duplication within the range, I know that it is a function. That's a later question they're going to ask us if it's a function or not. And the answer is that yes, it is a function, because none of those domain values happen more than once. Range, just list the y values, least to greatest, -2, 4, 5. Number 2. Domain. Looks like our -1, 0, a 1, a 2. We got them all. There was duplication there, because there were 2 1s. 2 happened twice also, so we know that this one's not a function. For the range values, I see a -5 is the smallest one. 2, 3, 4, 7. Number 3, we have to find f of 2. So plug in 2 and evaluate. So 5 times 2 plus 4. So 5 times 2, 5 times 2 of course is 10. And 10 plus 4 is 14. So we get 14 for an answer. Don't divide by the 2, it's not f times 2. Just f of 2 is 14. Number 4, f of -6. Plug in -6 everywhere there's an x. Order of operations says we would square first. And then -2 times -6 is going to be positive 12. Three times, so 108 plus 12 plus 11. So that's 131. Assuming I didn't make any errors anyway. Number 5, Naomi left from an elevation of 7,400 feet at 7 a.m., hiked to an elevation of 9,800 feet by 11 a.m., determine the rate of change in altitude per hour. So, take, let's see, per hour. So it wouldn't be a bad idea to think about making sure we get the things in the right place, numerator versus denominator, per hour, so we know hour is going to go on the bottom. We ended at 9,800 feet, so that'd be like my y2. So from it, subtract our original height of 7,400. So we ended at 11, began at 7. So 9,800 minus 7,400 is 2,200. That's right, 2,400, my bad. And then 11 minus 7 is 4. 2,400 divided by 4 is 600 feet per hour. Explain the sign, positive or negative. So that was positive. And make sure that you did it right. It should make sense. But I know it's positive because she's going up. She went from 7,400 to 9,800. Her distance was up. So she traveled up. So therefore it should be positive. It shouldn't be negative. Alright, graphing. This one, first one's in slope-intercept form, y-intercept of 2. And then my slope is 1 over 2, rise 1, run 2. So from here I rise 1, run 2. Rise 1, run 2. I could also rise a -1, run back 2 to get the other side of the graph. Connect the dots. It is an equation, so I don't have to do any shading. And it's just a line. It's not a dashed line or anything. That's just a line, no big deal. Number 7, now it's in slope-intercept, or standard form. I'll go the x coefficient isn't positive, but it's almost in standard form. It'd be easiest to find the x and y intercepts rather than putting it in slope-intercept form. Just remember your x-intercepts happen when your y value is 0, your y-intercepts happen when your x value is 0. So to find your x-intercept, plug 0 in for y. So 4 times 0 becomes 0. You're left with negative 3x equals negative 12. So divide that by negative 3, you get 4. So our x-intercept is 4, positive 4. So go on the x-axis to positive 4, put a dot. For the y-intercept, plug in 0 for x. So negative 3 times 0 is 0. We're left with 4y equals negative 12. Divide by your 4, you get negative 3. So our y-intercept is negative 3. It is an equation. We're not dealing with inequalities yet, so connect the dots. We've got our graph. Number 8. Y equals 4. Notice there's no x value in there, so it's like a y equals 0x if you'd prefer to think about slope-intercept. So the y-intercept is positive 4. Slope is 0. It doesn't rise. It's like 0 over 1. It doesn't rise, but it runs 1. So you end up with a horizontal line. Oh, so I kind of missed it. Good enough. Number 9, write an equation of the line. There's a slope of 4. There's our point, so we use point slope form. So y minus y1, which is a negative 2, equals my slope times x minus x1, which is 7, minus a negative 2 is like plus 2. So y plus 2 equals distribute, including the negative. Don't forget the negative, so negative 4x plus 28. Subtract the 2. Y equals negative 4x plus 26. Number 10, we need to first find the slope. So y2 minus y1 over x2 minus x1. Negative 7 minus 5 is negative 12. 6 minus 4 is 2. Negative 12 divided by 2 is negative 6. So now I know my slope. Now pick one of the order pairs. I'd probably pick the first one and just cross out the other one so I don't accidentally use it. Y minus 5 equals the slope, negative 6, times x minus the x, which is 4. Distribute the negative 6, negative 6x plus 24. Add the 5. And I get my equation. Y equals negative 6x plus 29. Same process for number 11. Find the slope. Negative 6 minus 4 over 2 minus negative 3. Negative 6 minus 4 is negative 10. Negative 2 minus negative 3. 2 plus 3 is 5. Negative 10 divided by 5 is negative 2. So I'm going to use my first order pair, the negative 3, 4. So we do y minus 4 equals my slope times x minus negative 3. That becomes x plus 3. Distribute the slope, negative 3x plus, sorry, not plus, minus 9. Add 4. So negative 9 plus 4 is negative 5. So y equals negative 3x minus 5. Number 12, this section, write an equation, slope-intercept form. Okay, we've got a point, and we're parallel to this line. If we're parallel, we have the same slope. So we're going to use the slope of negative 3. Now, I recommend crossing out that equation, so you don't try and use the 8 for any purpose. Point slope form, y minus negative 4 equals negative 3 times x minus 1. Y plus 4 equals distribute, negative 3x plus 3, subtract 4. Y equals negative 3x minus 1. Number 13, perpendicular. So that has a slope of negative 5, but if I want to be perpendicular, I do the opposite reciprocal. So negative 5 over 1 becomes positive 1 over 5. Done with that equation now. Use point slope form. Y minus 2 equals 1/5 times x minus 10. Distribute. 1/5 x minus 2. Add 2. I just get y equals 1/5 x. It'd be plus 0. We don't need to put the plus 0. Okay, back page. Okay, so we went through this in class. I'm going to go ahead and pull up a graphing calculator here. I'm going to go to Stat, Edit, put in my points. So there's already some numbers there, not the numbers I wanted though. You could clear them out, or I just overwrote them. 17, 10, 10, 7, 19, 12, 20, 15. I'm going to make sure that my stat diagnostics are on. They're not. So I'm going to fix that. Okay, it looks like my stat plot is on. I'm just going to make sure it's set up well. Okay, it is. Okay. If I graphed it, it shows the points. I'm going to go to Zoom. There's an option there, Zoom Stat. Quickly makes my window matches. Good. Now they're going to ask in number 14 about an equation of a regression line. So if we go back to Stat, over to Calc, the fourth option down is a linear regression in slope-intercept form. I'm going to choose that. L1, L2, I like that. I want to store it as a Y1, so I have to go to vars. I have a button right next to clear. Y vars, and it is a function. Choose Y1. I know I did that quickly, but we did it in class, so hopefully that's okay. Calculate. So my equation, I'm going to round these numbers because my a and b are long decimals, but so y is about 1.234, and then x plus my b about 5.574. As for predicting, because I stored it, this is already stored as y1. If I go to my table, I could go to graph, but I like to go to table. Go down to 15, where x is 15. I didn't have to scroll very far. And I see that I get 24.085. When you highlight it, you can see several more decimal places. But so it's about $24 an hour, or 24.09, I guess you could round it. Everything else is the nearest dollar, so I'd probably just say $24 an hour. What is the correlation? These questions should have been in reverse order. I'd have to go back to where I was at before, so let me do that. The correlation coefficient is the R value. So 0.98899. You know, you don't have to do all the decimals, but basically we want to see how close it is to 1. Describe the correlation. Since it's close to 1, it's strong, and it's also positive. So I would say it's a strong positive correlation. Or strong positive is good enough. If it was negative, I would have put negative. If it wasn't close to 1 or -1, I would have put weak. If it was 0, I would have put no correlation. Now graph. Pay attention to your domain restrictions, -2. It's helpful to keep that in mind. There's a, if you want to put an imaginary dashed line there, you can. But that's kind of the break point of my graph. I have to the left of that and I have to the right of that. Let's use the first equation, the x plus 2. I'm going to go to that line, -2. I'm going to plug -2 in there. So when I plug in -2, -2 plus 2 becomes 0. So I get the order pair -2, 0. Now, that is a closed interval because it was less than or equal to. So I know I can go ahead and graph that point. But now normally when I graph a line, like it's in slope-intercept form, so I have a slope of 1. Normally I would go up 1 and over 1 to the right, but that goes to the right and you need to go to the left. So if I have a slope of 1, I can change both the signs of the numerator and denominator. Think of it as negative over negative. So -1 over -1 goes 1 to the left, down 1. That puts me on the same line. I can continue to do that. And it's going to become a ray. It goes forever in that direction. So, but it has that starting point there at -2, 0. Okay, so there's half of my graph. Now I go to the other equation, y equals 3x, same endpoint or starting point, but I'm going to go to the other side. So I'm going to plug -2 and see what I get. 3 times -2 is -6. So I'm going to plot that point, but this time it's going to be an open point because this interval is when x is greater than or equal to. Or sorry, not greater than -2, not equal to. So because it's not equal to, I have to do an open circle. 1, 2, 3, 4, 5, 6. And now I can graph that line from there, and it has a slope of 3. So it's 3 over 1. So I could rise 3, 1, 2, 3 over 1. And I could continue to do that. Rise 3, run 1. Okay, and then we can connect the dots for that ray. And there's my piecewise function. You could go back through and erase that dashed line. You don't actually need it, but it can be helpful to put it there. Number 19. This one's a little busier. So 0 and 2 are my interval changes. So let's plug in 0 to the first equation. 0 plus 2 is 2. It's an open circle at 0, 2. And then I want to graph to the left. So slope of 1 over 1, so I'm going to make both an opposite, change to the opposite sign in both the numerator and denominator, so -1 over -1. So down 1, left 1. So I have that open circle, and then everything to the left of that is graphed. Then I'm going to plug in 0 on my second equation. 2 times 0 plus 5 is 5. So 0, 5. This one's a closed circle. So put 0, 5, put a closed circle. My open circle, since it's such a small graph, didn't really show up terribly obvious that it's open, so I'm going to redo that one. But now I have a closed circle. Put 5. And I go to 2. I might want to plug in 2. 2 times 2 is 4. 4 plus 5 is 9. So I go to 2, 9. And that's a closed circle also. So put a closed circle there. Connect them for that ray. And then we go over to -x plus 1. I'm going to plug in 2, because that's where the boundary starts. -2 plus 1 is -1. So go to 2, -1. Up, closed circle, open circle rather. And then my slope is -1, so I go down 1, 1 to the right. Go ahead and connect. Alright. Number 20, we get absolute value goes up 4. There's a -2, we think opposite sides, opposite directions, so that's going to be right 2. I'm going to start there by going right 2, up 4. And now, because it's positive, the v is opening up. 1/2 makes it open wider, and actually it's going to have a slope of 1 over 2, so rise 1, run 2. Then go back the other direction. So there's my absolute value. Number 21 is in standard form. I'd find my x and y intercepts, and then it also is an inequality. So x-intercept plug in 0 for y, we get x is -4. For y-intercept plug in 0 for x, we get y is -4. So -4 and -4 are both of my intercepts. Connect the points. It is a dashed line because it's not equal to, it's just greater than. And also because it's an inequality, I have to shade 1/2 of the line or the other half. So to check which half, pick a point that's not on the line. Like I like to pick 0, 0. Check and see if it's a solution. Plug it into the original equation. I get 0 plus 0 is greater than -4. So that's 0 is greater than -4. Well, 0 is greater than -4. That's true. It is a solution. And it's kind of up above or this upper right part, so I have to graph that entire or shade that entire upper right part of the graph. That's where the solutions are located. Number 22, it's also in slope or standard form rather. So let's find our intercepts again. Plug in 0 for y, 3x is 6, so we get 2. Plug in 0 for x, we get negative 2y is 6, so we get negative 3 for y. X-axis of x-intercept of 2, y-intercept of negative 3. This time it is a closed circle, because it's equal to. So draw a solid line. Not a circle, a closed line is what I meant to say. I have to figure out where to shade. I'm going to check the point 0, 0 again. I get 3 times 0 is 0, minus 2 times 0, it's 0. So 0 is less than or equal to 6. Well, that's a true statement. 0 is less than or equal to 6. So 0, 0 is the solution, so that entire side of the line, that upper left side, is where I would shade. Last section, identify the type of function represented. Number 23, I see it's an absolute value. I know that because of the absolute value sign. Number 24, it's squared, so that's quadratic. 25, it's a v, so that's absolute value. 26, it's a parabola, so that's quadratic. Alright, thanks for watching.